Hi everyone. Today we'll be taking a look at question 332 in LeetCode called Reconstruct Itinerary. So the idea is we're given a itinerary of destination and departures, and we want to construct it such that we have an order of them going from starting from JFK and including every single possible destination in the list. So to do this, we can imagine this as kind of a directed graph. So let's use paint to figure out what's really happening. So we have MUC goes to LHR. We also have JFK goes to MUC. So actually this goes this way. SFO goes to SJC. And LHR goes to SFO. So we can see that through this directed graph, all we gotta do then is we can perhaps do a DFS down the list to get every single destination, and then just reverse in order just to get the itinerary in correct order. So let's do that. Let's create our graph first. I'm going to be using a map for this. Our departure always comes first, so we can say and destination comes second. And now we're going to map it via departure to destination. So we can say if map departure doesn't exist, map departure equals destination, otherwise push it in. Cool, let's see what our map looks like right now. Awesome. So we just mapped out every departure to their respective destination. If a place has more than one destination, we want to sort them. As stated over here, where if one place has more destinations, has more than one destination, we sort them in lexicographical order. So let's do that. Or let value of actually just say for let map key console. Cool. So what do we do now? Now we have to do our DFS function where we're just going to go all the way down to the deepest destination and then return the reverse order. So the result equals empty array DFS. We're going to DFS starting from JFK because that's where we want to start from always. And here's our DFS function. We can say while the map has that destination, sorry, that departure, as well as the destination list is still not empty. We'll just keep on DFSing through the first destination. And then we're going to push them into our result in reverse order. So we'll say result to push, map, node. I believe this should be correct. Let me just make sure everything's okay. Oops, not map node. It should just be the node itself. Cool. So let's kind of see what's happening here. So our DFS function is going to go all the way down. So JFK has MUC, MUC goes to LHR, LHR goes to SFO, and SFO goes to SJC. And so since SJC is in an array, we're going to pop that out first. So our first thing is going to be SJC. Then we go to the next part of the call stack, which had the SFO. Pop that out. Then we keep going in reverse order. So then comes out LHR, then MUC, then JFK. Cool. So the last thing we then have to do is just return our result in reverse order. So you can say return result.reverse. Let's see if this works. Works just fine. Works just fine. Cool. If you're uncomfortable with how the DFS worked, you could also probably do this with a BFS where you just go down one by one in a queue until you reach one which has no destination and push them. In that case, you don't have to reverse. But I just think this is a little easier to write and understand. Cool. So runtime. We're putting everything into a map, so this is all O of n. And then sorting each of them lexicographically, sorting all the destinations is going to be plus k log k, where k is the longest destination array. And finally, doing the DFS is just another O of n action through the map, so we can ignore that since we already have the O of n here. So in total, this is O of n plus k log k, where n is the length of the circuit's array, and k is the length of the longest destination array. Cool. So with that, I'll put a link to the question as well as my GitHub down below. I'll see you guys next time.